So let's just review what we talked about during our last class. So in our last class, we worked on the idea of finding for a given set all the possible subsets. And we talked about when we're finding all possibilities, it's helpful to go about things in an orderly fashion. That way we don't miss any of the possible subsets. So at first we said the smallest subset is always the empty set because there's no elements. Then we've got to think of the subsets with one element, then with 2, and then with 3. So for the set 2, 4, 6, it had 8 possible subsets. What were the possible subsets? We have them listed here. And notice the largest subset is the set itself. Now for the set B, 2, 9, we were asked to find all the possible subsets. We know that the smallest one is the empty set. Then you could have the set with just the number 2, the set with just the number 9. These are both one element subsets. And then you could have the set itself, which is a 2-element subset. So there are 4 possible subsets of the set beginning 2, 9. Now we know the empty set is the set with no elements. So the only subset of the empty set is itself. And for a subset U that has only one element, for instance, maybe the set of just the number 5, then it is a subset of itself, because everything is a subset of itself, and the empty set is a subset of it as well, because definitely that the empty set is a subset of everything, and it is always a subset of itself. So the key thing to know is if you've got a set starting with, let's say, the number of elements in the set, and then we relate that to the number of possible subsets, we're going to see a pattern. So let's think, what's the smallest amount of elements in a set? The smallest number is 0 if your set is the empty set, right? There's nothing there. And then you could have a set with only one element, a set with only 2 elements, like our 2, 9, or you could have a set with 3 elements, like our 2, 4, 6 set, and it could keep going on and on like that. Well, whenever we had a set with 3 elements, we found earlier that there were 8 possible subsets. Okay, and there's always going to be 8 subsets. No matter what 3 elements are in your set, they're going to form 8 possible subsets. And when there's 2 elements in your set, we saw that that formed 4 subsets. Okay. And whenever you've got a set that only has one element, it's got itself as a subset and the empty set, so there's 2 subsets that go along to that. And whenever you're the empty set, the only subset is the empty set itself, so there's only one possible subset. So what we've done here is we've kind of compiled information of, well, what happens to the number of subsets as the number of elements in the original set increases? Notice as we get more elements in the original set, definitely the number of subsets increases, and it increases by a pattern. Do you see to go from this to this we multiplied by 2, from here to here we multiplied by 2, here we multiplied by 2. Each element that we add to the original set, that ends up multiplying the resulting possible subsets by 2. And the way you want to think about this example is there's going to be one formula that we want to keep in mind. The number of possible subsets is equal to, so if you start off with a set with n elements, so n is taking the place of the number of elements. We saw the example for 0, 1, 2, 3, but you could have more elements in your set than that. Then the formula is the number of all possible subsets, which we would get from this row, is just 2 raised to the n power, where this is an exponent. And let's look at an example using this formula first. So for this example, which I just turned to the next page, we'll go back to the previous page in a second, but let's practice using this formula. It says find the number of subsets and proper subsets of this set. We just learned the formula for the number of subsets is 2 to the n, where n is the number of elements in the set. Okay, so we've got 1, 2, 3, 4 elements in our set. So the number of subsets here would be 2 raised to the 4th power. Notice this is different than 2 times 4. Okay, exponents are saying raised 2 to the 4th power, which you could type into your calculator as 2 exponent button 4. But if you don't have an exponent button in your calculator, you can still find it because exponents are repeated multiplication. So 2 to the 4th is 2 times 2 times 2 times 2. 2 times itself 4 times. In either approach, we would get that these are equal to the value 16. So there are 16 possible subsets of y. And if we wanted to, we could write them all out like we did in previous examples, but we don't have to in this case because we just wanted to find the number of subsets, not actually what all these subsets are. So this is the number of subsets is always 2 to the number of elements of the original set. And in terms of our practice problems from this section, if you look at the second page, this is the relevant question here. You're given sets, and in part A, you're asked to find the number of possible subsets based on the set being described. So that's where this comes up on our homework for 2.2 notes. Now, last week we discussed the idea of what is a proper subset. Let's review the idea of proper subset. Okay, we had on page 8 that a set is a proper subset if it's a regular subset with the additional condition that it can't be equal. So you can be a proper subset as long as you're not actually equal to the set, right? You're just a regular subset plus not being equal. Now I'm back on page 9 here, and for practice, let's look at this first example. Do we see I've got these 8 subsets listed here? The 8 possible subsets. Okay, focus your attention here. One of these 8 possible subsets is not a proper subset. Which one is it? Think for yourself. Remember, they're all already subsets. That was part of our list. What makes something not a proper subset is if it's actually equal to the set itself. So the largest subset, the set that's actually the set you began with, is not a proper subset because it's a subset that is equal to what you started with. Okay. So while there are 8 possible subsets of 2, 4, 6, there is only 7 proper subsets. Because the largest subset is not a proper subset. Now for practice, why don't we apply similar reasoning to the next example? So for B, which is the set 2, 9, we found there's 4 subsets in all. And which one of these 4 subsets is not a proper subset? Think about that to yourself. We know that all of these are subsets, so the one that's not a proper subset is the set that equals where we started. So while there's 3 possible subsets, there's only 3 proper subsets. So do we start to see a pattern here? Once you know how many subsets you've got, the way to know how many proper subsets you have is it looks like you just subtract one, right? And that's exactly what happens. So if you already know how many subsets you have, then you know how many proper subsets you have because you just have to subtract 1 from the number of subsets. So if we had 8 subsets, we had 7 proper ones. If we had 4 subsets, we had 3 proper ones. And that brings us to the formula about proper subsets. The number of proper subsets of a set with n elements is the number of subsets, 2 to the n minus 2 to the n. And then what you do is once you find this value, you subtract 1. And notice it's got the same beginning part. This is the formula for subsets, 2 to the n. And when we talk about proper subsets, we just have to subtract 1 from that value to get rid of the largest subset. So with these two formulas, you can find the number of subsets and the number of proper subsets. And in both cases, you first have to count how many elements are in the original set that is part of the problem. So turning the page, let's finish this last example. We already found the number of subsets. Now let's find the number of proper subsets. And why don't you actually pause the video here and attempt it on your own based on what we already found here and our formula for the number of proper subsets on our previous page. Okay, when you're ready, unpause the video and you'll see it discussed for you. We already found that there are 16 subsets in all, and the only subset that is not proper is the largest subset A, B, T, U, the set itself. So we only need to eliminate one of those options from the 16. So it's just going to be 16 minus 1. There are 15 proper subsets. Now the way you could have found this based on the formula is there are 1, 2, 3, 4 elements in the set. 2 to the 4th that you then subtract 1 would give you 16 minus 1 as well. That's just another way to do the problem. Let's go to some of our homework from this section. Okay, now remember, right now I'm posting homework problems since there was a slight delay from the bookstore with the textbook, but later I'll start assigning homework problems from the textbook, so just make sure you're in the process of getting access to the textbook, however is best to you. And to begin with, why don't we work on 2.2 homework, and I'll post the solution to these later. Solutions will be posted to Canvas. Okay, later tonight, so that's later Monday night. But it would be best for you to attempt all these problems on your own first, and then check your answers versus the solutions. If it's correct, mark that on your paper. If it's incorrect, try to see why it would need to be corrected. And if you're unsure, you can always send me questions. I'll be happy to help. I can even make short little videos to help explain what's going on. So if you would do these problems, then you're going to see a 2.2 quiz posted to Canvas in the week 2 module. And if you've done all these homework problems and you understand it, you'll be well prepared for the week 2 quiz, or the 2.2 quiz. Now let's do one of these problems together. For this problem, it says A, find the number of subsets, and B, find the number of proper subsets, which is kind of what we did just previously. And if you notice, we've got 3 separate problems here. Okay. The set of the days of the week, again, this is a word description. It might be helpful to write out exactly what is that. That's Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and then Saturday. So we see that there is 1, 2, 3, 4, 5, 6, 7. So to find the total number of subsets, that's 2 to the 7, because you just raised 2 to the number of elements you have based on our formula. And to find the number of proper subsets, B, you would just subtract 1 from this number. So it's 2 to the 7 minus 1. Now, if we want to know what 2 to the 7th is in our calculator, we would type 2 exponent 7. And if you don't have this exponent button, then you would just multiply 2 by itself 7 times. 1, 2, 3, 4, 5. Okay, that's 2 to the 7th. And in either case, we would get 128 as our answer there. So 2 to the 7th is 128. So the answer to part A is just 128. But for B, you've got to subtract 1 from that, so it'd be 127. And you would do a similar thing for the first problem and the third problem. It just depends on the number of elements in your set. The formulas are the same for proper subsets and subsets. So work on these 2 pages of 2.2 homework problems. Then when the solutions are posted later tonight, check your work. Seek help on any questions that you have just to clarify these concepts. And then when you're ready, you would go to our course's Canvas page and modules. And if you go to week 2, later today, once I've got a little bit of time after my classes, I'm going to put a 2.2 quiz in week 2, similar to how the 2.1 quiz was in week 1. So later today, you're going to see the link to the lectures for today's classes here, along with eventually the 2.2 homework solutions, similar to this, and then after that, the 2.2 quiz. So it's going to follow a similar structure to week 1, so just look for that, and also you can check your Canvas inbox for announcements. Now we are going to continue with the remainder of today's lesson, which is going through 2.3 notes, but I'm going to address that in a part 2 of this video, so you're just watch part 1. So look for a link later in the day to part 2 of the video. I'm just sending link 1 now so that you can get started watching when you have time. And then later today, I'll finish the notes for 2.3 and post that video as well. If you have any questions, please let me know. I'll be happy to address it. And we'll see you hopefully in Wednesday's class. Thank you.